Hello, everybody. Can you hear me correctly? Yeah? Oh, perfect. So first of all, I would like to thank all the team here for this big conference and also the sponsors. Before we start, just want to know if there is people who doing some web scraping here, just by raise your hand, okay? Some doing some hacking here? No one? Or please all raise your hand, no? Okay. Um, so my name is Fabien Vauchelles. I've been deeply passionate about web scraping for years. My enthusiasm led me to the fascinating world of proxy and anti-bot systems. I work at Wiremind, an amazing company specializing in revenue management within transportation industry. Our work at Wiremind involves handling millions of prices on a daily basis, which require a substantial investment in web scraping technologies. Our infrastructure, web data collection infrastructure is pretty big, many built on open source tech. I'm also the creator of Scrapoxy. Scrapoxy is a free and open source proxy waterfalls. It allows you to manage and route traffic through cloud providers and proxy services. Who already knows Scrapoxy? No one? Yeah, awesome, it's cool. So it supports major cloud providers such as AWS, Azure, GCP, and DigitalOcean, and also proxy services like BrightTime, Wiremind, IPRL, and many others. I've got some cool sticker here if you want after the presentations. So since I started the project version 4 in February 2024, over 200 users have installed Scrapoxy. They exchange 70 terabytes of data and send 1 billion requests and use 1 million proxy. So it's a good start, and if you want to try, don't hesitate. So before we dive, I would like to share with you a little story. A decade ago, I found myself within a conversation with a friend who worked in the HR industry. This was a time where AI and NLP were just at the beginnings. During our conversation, we stumbled upon an idea. It is always challenging to identify potential candidates in the IT industry. So we wondered, what if we could predict if someone might leave their job within the next 2 or 3 months? This way, we could offer them exciting job opportunities. And believe what? It works. But it's unlike a brilliant concept on paper at times. And as you probably know, machine learning algorithms need large amount of data to train. So we need profiles, millions of profiles. And we thought, okay, let's go and gather them. But the real challenge came when we tried to collect hundreds or even thousands of profiles. I hit a wall. I was barely new to web scrapings. I checked on Stack Overflow for solutions, and the advice was to use proxy. Okay, so proxy were very expensive at this time. So my idea was to buy a virtual machine on Amazon and install a Squid proxy. So I will get a fresh IP address. It worked a little bit, but I always face the same problems, blocked. So how can I get many fresh IP addresses? The answer came into the form of a basic script by destroying, creating, and automatically installing new VMs. I will get fresh IP addresses. And this was the birth of the Scrapoxy project. But my journey had just begun. Using VM from cloud provider doesn't prevent you from being blocked. And there was something I didn't understand at this point of time. It was the Turing test. So let's explore another examples. When we purchase a ticket to go to this conference, it seems like, hey, I'm a human living in Paris, and I'm so excited to be to this conference. I'm bringing a ticket, round-trip ticket, during the evening, using Safari on Mac, and I use a DSL connection or fiber connections. So these interactions reflect a natural and organic behaviors. But when it comes to web scraping, it's more like, hey, I'm Scrapy, living in a data center in Ireland, and I'm not interested to travel to this conference. My goal is to retrieve thousands of prices from many airlines. I'm accessing to data with a deep link at 2 a.m. using a Python library within my Docker. My internet provider is AWS, and I love to randomize my parameters to seem to be a human. Honestly, it doesn't seem to organic behaviors. And the website understands that, and the antibot too. And you see, they conduct Turing tests on your behalf. So the question is, how do antibots systems assess us? They meticulously check our browser stack. Starting from our IP address, they know where we are coming from. The protocol header divulges details about our operating systems, the browsers, the versions. And they execute JavaScript to get our system configurations. And on top of that, they track our navigation patterns, like the sequence of web pages, the sequence of events, such as mouse movements. And they cross-reference all this signal to get and validate the consistency. So now, let's dive into each layer of the browser stack. So the initial layer is the IP address layer. It is the very first piece of information a website obtains when we connect to the website. Are we connecting from an internet box? Are we connecting from mobile phones? Are we connecting from a data centers? For instance, if we are purchasing a ticket from Paris to New York, is our connection originating from India? If we are using IP US addresses, is our time zone is based in Western Europe? It can be very inconsistent and be flagged and detected by the antibots. Moving to the second layers, let's understand the protocol, the power of protocol headers. So in this part, we can distinguish 3 protocols. So first up is TCP protocol, second is TLS protocol, and the next one is HTTP2 protocols. Okay. So first up, the TCP protocols. The RFC describes how operating system should implement the TCP protocol. But in practice, the implementation often varies not only from one operating system to another, but even between the different versions of the operating systems. And by analyzing each header statistically, it is possible to deduce which operating system is sending the packets. So summing it up is the TLS protocols. The Transport Layer Security Protocol is an encryption protocol on top of the TCP protocols. And it is used everywhere. So here is an overview of how it's working. When a browser wants to create a secure connection, it initiates a negotiation with the server. This negotiation is called the handshake protocols. And during this process, the browser sends a client hello message. This message includes a list of supported encryption protocols such as RSA, DSA, and some options. It is called the cipher suite. Who knows that? Okay, some of you, that's good. After that, the server selects the most secure algorithm and compatible protocol, and they exchange a key exchange. And after, the transmission is encrypted. And this is where the magic unfolds. Each browser has its unique cipher suite and options. This leads to the creation of a TLS fingerprint known as the J3 fingerprint. It was invented by Salesforce. So with this fingerprint, we can identify if it is Chrome browser, Firefox browser, Edge browser, or a Go library, a Python library, or Node.js library, which can be an automated systems. And third up is the HTTP2 protocols. HTTP2 headers resemble to TCP headers. The browser implementation introduces variations on setting, field order, priority flags, etc. And by examining statistically the headers, it is possible to deduce which browser is responsible for sending the packets. So now, I know that you should think where I'm heading with this. Imagine that you claim to be a Firefox browser on Windows, but your browser stack suggests that you are Chrome on Linux. Clearly, it's a red flag, and it could lead to a ban. And of course, it doesn't end here. We can also fingerprint the HTTP protocols. If we look at the HTTP headers, we can get a lot of information. So here is a small code from a well-known anti-bot system. The code is public on internet. You can find that. So it's just 4 lines of code, but it's bulletproof. This tiny little function just gets the list and order of headers. That's why, because when we code a spider, a scraper, we try to strip away as many headers as possible to keep the code simple and maintainable. But when you read these functions, you understand that all headers are vital. Even they are not using for the API, they are crucial for the fingerprint process. And with these functions, you can get rid of most of the spider in the world. And of course, all browsers can execute JavaScript. It is truly astonishing how much information they can get from JavaScript. They can get detail like our time zone. They can get the detail like the GPU models, the GPU fingerprint to check the consistency with the GPU models. They also can get the number of speakers, the model of speakers, the number of microphones, the camera. Do you have a battery? So you are a laptop or perhaps a mobile phones. They can know the list of font installed, the list of plugin installed, extension installed. They can know if you have an ad block. They can get your real IP address. If you leak your real IP with a WebRTC leak, they can know the browser size, the screen size, everything. And if you are using Android, they can know far more information. They can know if you are using Android debug, so you are doing reverse engineering. They can know your device architecture, because if you are using Intel architecture, it's not common for a smartphone. It's not ARM architectures. So perhaps you are using an emulator. They can know the device model, the Android version, and the unique install ID of your mobiles. So they can track you everywhere. And of course, it's not finished. They can get also how you act on the website. Anti-bot systems observe the sequence of web pages we visit. Do we initiate our journey with a search query, or do we access to data with a deep link directly? They can know also if you are executing JavaScript and loading CSS, or only fetching HTML. They can also track the timing of events. So they can track the timing between different web pages. It's close to rate limits. They can get also the timing between events, and they also track the mouse movements. Because we are, as humans, we are moving the mouse in a natural, fluid manner, often resembling to basic curves, as opposite to a bot which use straight line movements. And all this information are transmitted at interval to the web server. That's why sometimes you navigate smoothly to a website, successfully getting some response, and suddenly you get a CAPTCHA. That's because your reputation score gradually decreases over time and goes through a threshold, and the web server decides to send perhaps a CAPTCHA to check if you are a real human or just blocking you. And everything, all these signals are combined together to create a binary classification score. Algorithms blend everything with machine learning techniques to rate the browser sessions. And to improve and adapt over time, they use reinforcement algorithms like cat boost, if you know that. OK, if we examine the previous stack, it became evident that trying to outsmart the Turing test can be very challenging. However, there is a vulnerability. Do you know that? Which vulnerability it is? No? And this vulnerability is the false positive. So let me share with you another examples. So last year, I wanted to buy some train ticket online. I was using my laptop. I don't use my laptop to do web scrapings. I'm not using also my IP to do that. But when I connected to the web page and tried to buy the ticket with my credit card, I was just blocked, and with a message stating, "You're a bot." I finally understand months after why I was blocked. It's because I'm using Linux. Woo! Okay, they blocked me because I'm using Linux. No problems. I just switched to the competitor website. And they just lost one customer. It was a false positive. So it happens all the times. They raise too much their security levels, so at the end they need to lower the security levels. So if you are running a business, false positives are something that you want to avoid at all costs. An anti-bot system must adapt to that. And to do that, there is two approaches. So if you did a little bit of data science, you know these approaches. So first one, if you want to correctly train your algorithm for each signals, you need massive volume of data, so clean record correctly tagged for each signals. This is clearly too challenging, too expensive, unless your name Googles, so that's something they skip. Instead, they focus on the effective one. And that things that you should know also that some signals can be very difficult to collect, like the protocol headers. It's very difficult to get them because you need to be root, you cannot have them with Kubernetes, so it can be difficult. So nowadays, commercial solutions track between 100 and 200 signals. And most of the times, so anti-bot rely on IP informations, HTTP headers, JavaScript execution, behavior trackings, and now they start to use TLS fingerprint. So now our objective is to understand which commercial solution is installed on the website. And for that, there is a wonderful extensions. Perhaps you know that. Who know WAPalizers? So yeah, it's a very cool extension. It gives you all the security, all the technology on a website, and as I said, the security technologies. And you can compare that with the Chrome Dev tool on the network inspector. You will find some creepy requests. Most of the time, it's the anti-bot. And if you dive into this request, you will have some strange cookie, encrypted cookie, which are the anti-bots. And if you are using Android, we can rely on any interceptors, such as Scrapoxy, HTTP Toolkit, Burp Suite. There is a lot of product to do that. And furthermore, when we deal with anti-bot system, it is easier to use Android applications because it's Java source code. And you can decompile the Java source code using tools like JDX and perform injection with Frida. So you can understand how some headers are generated, especially the IDs in request, because they often pop up from nowhere. So you have to check the code to know how they get this kind of ID. So now let's understand how an anti-bot system works. What is the anti-bot architectures? So you have the browser, the website, and the anti-bot. So when the browser connects to a website, it also connects to an anti-bot URL. This URL may be hosted on the website or on a dedicated website. It depends. So first, with JavaScript, the anti-bot collects a lot of information, so configurations, events, and so on. After, this payload is encrypted and sent to the anti-bot. In return, the anti-bot issues a cookie for the browsers. And now when you connect to the website, you send the cookie along with your request. So now, it's very simple. The website can initiate server-to-server connections and retrieve a reputation score. And based on this score, the website decides to either grant or deny us access. So now, let's take a closer look how the anti-bot secures its payload. There are many methods for securing the payload. You can use base64 encoding or even asymmetric encryption. I will focus on the most advanced one, so asymmetric encryptions. First, the obfuscated code on the browser will collect all the information, so browser informations, configuration, events, etc. These data are structured into a JSON as an examples, and they use internal keys, so to make it more difficult to interpret which signal each signals. After that, on the browsers, they use RSA encryption algorithms. The public key is stored in an obfuscated way on the client code. With that, they encrypt the payload. The payload is sent through a post request to the server, and the server, which has the private key exclusively, can decipher the payloads. And since the server owns the private key exclusively, it is impossible to decrypt the payload with man-in-the-middle technique or Chrome DevTools. Okay, so as we saw, it is difficult to handle anti-bot systems. We need a methodology for constructing a scraper because website and protection quickly evolves. So additionally, it is important to note that not all websites are equally protected. Some websites have no protections. Some websites have very small protections, and some websites have very hard protections. So using the same approach for every website can be costly and time-consuming. So we need a methodology to tackle all these websites. So I will share with you a proposition of methodology, a generic one. So imagine that you already have a spider, a scraper. You use perhaps the famous Python framework, Scrappy, okay? So you already code everything. But it's not working. So it's time to tune the spiders. You can adjust the delay between requests, the number of concurrent requests. You can align the HTTP header, so having something consistency between the user agent and the all other HTTP headers. You can also adapt the referrer. Are you using cookie or not? You can change the TLS versions. That can work. You can change the payload, the order of requests, etc. There is a lot of options. But if it's not working, perhaps it's because we are sending all the requests from the same laptop or the same server. So we need to introduce a proxy. So the proxy concept. So what is a proxy? A proxy is a system on the internet which will relay your request to the website. So instead of seeing one IP address sending millions of requests, the website will see a lot of IP addresses sending few requests. There is a lot of type of proxy, so you can use data center proxies. They are fast, cheap, and reliable, and you can add also the Scrapoxy layer to correctly orchestrate all your proxy strategy. But if it's not working, it's perhaps we are not acting like a browser. So we need to introduce what we call headless browsers. So it's a browser running inside a containers, a Docker containers. There is a lot of framework to do that. There is Selenium, Puppeteer, Playwright, and a bunch of plugins to skip the JavaScript fingerprint. If it's not working, it's perhaps we are using very basic type of proxy, so data center proxy. It's time to introduce more advanced proxy. There is different type of proxies. There is ISP proxy, residential proxy, mobile proxy, hardware proxy. So what is ISP proxy? It's like data center proxy, but they don't use the IP address from the data center. Instead, they will rent IP address from a mobile carrier or internet box providers. So they rent their IP range, and they can be undetected. The residential proxy is a little bit different. So it's when some user want to gain some money, so they share the bandwidth, so of the laptop bandwidth, the mobile bandwidth, they share the IP address. That's where the residential proxy comes from. It's very interesting because perhaps the same IP address was used just a minute ago to connect to famous social platforms. So it's a clean IP address. There is also mobile proxy. So this kind of provider owns a lot of 4G key in front of the antenna, perhaps 1,000 too, and they rent for you the 4G key. Also, you can do that yourself. There is hardware to do. You can have this kind of hardware and plug the 4G keys. If this kind of proxy is not working, perhaps it's because automation is detected. So we need to shift to helpful browsers. Yes, Puppeteer, Selenium, and this kind of automation framework can be detected by antibot. I will talk about that later. So to avoid that, we can construct a stack, an open source stack, but there is commercial solution to do that. And if everything is not working, you can use what we call Unblocker API. It is commercial ones, but they will do all the previous steps for you. To be honest, it depends on your budget. So I'm not using that, but if you want to quickly jump to this step, it's possible. And if sometime you need to solve some captcha, there is a very fast AI captcha solver. Please don't use human captcha solver. It's not very ethical. And the AI captcha solver are solving captcha in 2-3 seconds, so better than you, so it's faster. So now, if we translate this methodology into an architecture schema, okay, it can be the following one. So first, we built a scraper. It collects data all around the world. But as we grow, we need a better organizations. So we need to set up a place to store all the collected data and the URL frontier. So what is the URL frontier? The URL frontier is a list of URLs that you already visited and that you need to visit. This means we will introduce two important components. First, a database, and second, an orchestrator. In addition, we often use a broker to distribute the task, such as RabbitMQ. And second, we realize that using just one IP address is not enough. So we need to add proxy. We can add the Scrapoxy layers to manage all this proxy. So it's cool because it comes by default with all cloud provider connectors, such as AWS, Azure, GCP. And guess what? It's important to know that all these cloud providers give you free massive credit for startup. So it's a good start to create your own private proxy pool for nothing. And sometimes, even with new IP addresses, things don't go smoothly. So we need to add different type of proxy like ISP proxy, residential proxy, or mobile proxy. And of course, Scrapoxy can handle everything smoothly without coding anything. And we also learned that we need to introduce JavaScript executions and to add clearly headless browsers. But rather relying on a single browser, we will create a browser farms. So with Chrome, Firefox, Edge, Safari inside, and many operating systems. However, this is the most tricky part, because there is no free and open source tool on the market to do that. So you need to write it out on your own. Okay, so with this infrastructure, I think we're ready to scrape the web. You're good from now? Yeah? Okay. But I didn't disclose you the whole truth. The web is divided in two categories. So on one side, you have 80% driving half of the internet traffic. On the other 20% side, they drive the other half of the internet traffic. And here, we are talking about major e-commerce websites or social platforms. And because these websites drive a lot of traffic, they use the most advanced protections, the most advanced commercial protections. So our previous generic approach won't fully work, and the success rate will be clearly low. So this time, we need to identify precisely which signals they are using and how we can emulate them. So if you remember the previous architecture schema, so the signals are embedded into the payloads. But the payload is encrypted, so it's impossible to understand it with classic man-in-the-middle technique or the Chrome DevTools. So we must trace back to the payload generation process. And the payload is generated within the browser code of the antibot. But the code is obfuscated. So what is obfuscation? Who knows what is obfuscation? There was a good talk before. Yeah, cool. So obfuscation is the art of rendering code incomprehensibles. I know that we all have that one colleague who excels at making the code incomprehensibles. It's perhaps ourselves. But here, what I'm talking about is something to a whole new levels. When the code is really obfuscated, you cannot understand what the code is doing or why it's working. And now, the art of deobfuscation is the art of making sense of obfuscated code. And it's not a simple mirror operations because it can be very challenging. So now being able to read obfuscated code clearly is a giant step. And to understand deobfuscation, we need to see some obfuscation method to better understand how it's working. So let's walk through some technique about string obfuscation and code flow obfuscations. But before that, we need a tool. And we will use a tool called Babel.js. Who know Babel? Some of you? So Babel is used in front-end development. Basically, it's used for minification, so to reduce the code size. So what does Babel do exactly? It takes your source code, which is a string, and transform it to an abstract syntax tree. This tree represents every operations of your source code, so such as function declarations, binary expression, etc. Then we will apply some transformation to this tree. And believe me, it is far more easier to apply transformations to a tree than to text string source code. And after that, we finally use a generator to convert our tree back to obfuscated code or deobfuscated code. So now let's walk into string obfuscation methods. So the first one is string bracketing. So in many interpreted languages, it is possible to access to method or values through object keys. And this key can be transformed from dot notations to string notations. So it stays readable. You agree? You can read that? OK. So we will cut the string with string splitting. So if we break the word screen, we can break it in SCR and EES. It is harder to read, but you can still understand that. That's why we will introduce constant unfoldings. So here, instead of using string, we will just use random constant group at different places of the code. And when you read the last line in red, you cannot understand the meaning of the operations. But we can still refer to the constant definition to figure out the actual value. That's why we will use encryption functions. And this technique is called string concealings. So in this example, I use a very simple base64 encoding. But keep in mind that antibot systems use far more advanced functions, and they combine hundreds of techniques, hundreds of methods at different places to make it impossible to read. So that's what about string obfuscations. So now let's jump into code flow obfuscations. So the first technique is code flow confusions. So the goal is to extract all the possibility of the JavaScript interpreter. So here, we can alter the conditions. So normally, if the conditions evaluate to true, it will execute the code block. But we will make the code block disappear. We will introduce, we'll put the code block inside the expressions. So as you see, it is more complex, but we can still read it. That's why we will introduce dead code. So dead code is exceptional. So it's both same expression assignment, the value 10 to A. And as you see, I added a lot of code, which is not executed and useless. But imagine that if you inject this code in the previous condition, it can be unreadable. And obviously, anti-bot system will have very, very long expressions everywhere. And in addition, we can combine that with scope confusions. So it's a very simple idea. Just name everything A. And if there is scope collisions, you can use perhaps B and sometimes C, and so on. So in this example, I just change valid to the name B. However, I also introduce into the code block a constant B. So in the code block, which B are we referring to? It can be confusing if you have 10 variable introductions in the code blocks. And I love the last one. It is probably the sneakiest method out there. So what exactly is control flow flattenings? So the objective here is to convert sequential code into a state machines. It's like adding go-to point in your code. So you will end up with a single state machine for all your functions. It turns debugging into a nightmare. You cannot follow anymore sequentially the instructions. And it's very difficult if you add all these techniques. I won't go into detail on deobfuscations. You need to determine the right sequence of method for that and to try one by one the different approach, perhaps multiple times, and you will get some deobfuscated code. So now, let's say we successfully deobfuscate the code. We need to identify the signals inside the payload. And there are 5 types of signals. So the first set of signals are about configuration details. These include browser setting, OS characteristics and configurations, event, etc. These are aspects we already discussed previously. The second set of signals is about automation detections. I already told you that tools like Selenium, Puppeteer, Brave Browser introduce JavaScript objects. These objects are introduced for interactions. And anti-bot systems love to check this object because it's a red flag for automations. The third set of signals focus on graphic rendering. This involves drawing graphic on a hidden or offline canvas and fingerprinting the renderings with a hash. You do a hash of the buffer. It is important to know that the rendering depends on 3 components. First one is the browser, second is the operating system, and third is the GPU. So if you are using a dual boot with Linux and Windows and rendering emojis, they have very different style on Windows and Linux, so the hashes can be very different. If you are using 2 different browsers on the same Linux, you will have different hashes, and if you activate or deactivate the GPU, so switching from GPU and CPU, the rendering can be different. And if you check the declare model, remember, on the configuration, the declare model, and check the hashes, you can have surprise. And the fourth set of signal is trying to counteract reverse engineering. A common technique of JavaScript is to get the source code of functions. So if you are using toString on query selector, so here you're not executing query selector, you're getting the source code, you will get 2 words, which is native code. But if you are monkey patch these functions, typically, that things that you do with polyfills, the result will change and you won't see native code anymore. This is how anti-bot system detects that you are trying to emulate some behaviors. And the last set of signal, control integrity, is mostly simple or complex checksums. So if you modify configuration before, don't forget to modify the checksums. So that was all for the signals. Now I would like to share with you some spotlight. So what's next in terms of protection in the coming months? So remember, when we try to deobfuscate the code, so we have the obfuscated code on the browsers, we try to move up to the deobfuscated code, to the real source code. Now, anti-bot system introduced a new layer, which is virtual machines. It is close to the Java virtual machines. So the JavaScript virtual machine execute bytecode these times. However, this bytecode is proprietary and undocumented. So when you've got the obfuscated code, you deobfuscate the code. So what you have is the virtual machine and the bytecode. But what can you do with the bytecode? Barely nothing, because it's a very complex task to move from the bytecode to the source code when it's not documented and proprietary. So that's it for me. I hope that you enjoy the sessions. Here are some open source tools if you want to know more about anti-bot systems. So thank you very much. Download Scrapoxy, join my company, and I will be very happy to answer some questions. Yeah. There is a mic.
Hello, and thank you for sharing this awesome presentation. I wanted to ask something, but let me give some context. So I have a friend that is scraping data using an RPA solution is UiPath, and it works great besides the fact that it takes a lot of time. And I wanted to ask you if have you tried RPA solutions for scraping, or what are your thoughts on this? Thank you.
It depends on what you want. Remember when I presented the unblocker part, it's kind of API solution. They will do all the work for you. The thing is depend on the volume. If you want to scrap million of data or billion of data, perhaps on a daily basis, it can be very expensive to use these kind of APIs. So it doesn't work the game. So you need to build everything yourself to lower the cost. When I say lower the cost, you cut the cost perhaps about 1,000. So that's why there is not so much usage on web unblockers. But if you want to focus on your core business, which perhaps is not data collections, perhaps you will use that and invest a lot of budget on this kind of APIs. It depends. Also, it's a matter of speed, as you said. If you want to gather millions of data every day, you need to master the infrastructures. Imagine, I already have that. Your provider is shut down tomorrow. You're dead. So you need perhaps to have 2, 3 providers. I've got 20 proxy providers myself. So I've never been led by one of the proxy providers. Other questions? Everyone are okay on? Yeah, perfect.
Yeah. Are there some tools for solving them?
Yeah. There are different methodology for the captcha solvings. If you want to use commercial ones, I put you some. They are very effective. You can see that they click very quickly on Google reCAPTCHA 3 for enterprise or Datadom CAPTCHA, so it's amazing. Otherwise, you can use also open source solutions. So now with the latest convolution models, they can clearly analyze that. Also, when you have text or questions, they use LLM to solve that. So it's very efficient now.
But I'm referring on the less complex ones, like when you need to find some code, or maybe there is a clock somewhere, and it's really hard for me to solve them. What about an AI?
Yes, so you have to code it. The guy who built this kind of product clearly adapt. So there is a little time. You know, it's a cat and mouse games. So there will be solutions. But what they are doing now is to remove the visual part because it's clearly annoying. So even you are a real user, you've got a CAPTCHA, you cannot solve it. So you cannot buy your ticket. And remember, it's a showstopper. So what they are doing now is to not showing anything. And what they are doing behind, they are collecting all the information, tracking the GPU. I think it's far more efficient to do that.
All right.
And you can, if you invest a lot of time, clearly bypass this part. I've got friends who take months to reverse engineering protections. And it's very crazy how they think the protection, they rotate the obfuscation. You know, you have the obfuscations, part that I show, and it changes every 30 minutes. So it's crazy.
So, assuming that your company forces you to use the company laptop, and they have Okta, and they fingerprint the device, you log on to company applications, you prefer to use your own laptop. How could you fake the company laptop on your personal device so that it can still access applications?
Certificates, I think. How do you fake? I think on authentication like Okta, if you're a company and you correctly secure, use certificate on your laptop. So the certificate is installed, and it's not a simple login password with MFA2. You see there was a lot of talk how to bypass MFA2. So I don't believe that it's the most efficient part. So perhaps if you're using certificate installed or something material, yes, you correctly secure the part. Otherwise, you can bypass that. Am I answering correctly?
Sort of, yeah. What I've seen in the Okta process is that it uses a fingerprint. It has fingerprint JS somewhere in its guts, and it outputs some token. And I thought that was the key.
They use more and more the fingerprint process to counteract this kind of issue. Not everyone can install a certificate. So they use behind a hidden fingerprint, so collecting browser information, matching with the TLS, matching with sometimes with the TCP part. It's very rare, but some are doing that. Yes, and it's a combination. I saw a talk from R&D guys of an antibot system, and he's able to detect, it's the beginning of the research part, he's able to detect a residential network. So residential network is my laptop. So how can you detect that I'm sharing my bandwidth? Perhaps it's my son in my home. I don't know. So how can you detect that? And they are able to identify that. The answer is use combination of different layers.
Thank you.
Yeah.
Do you see your solution, Scrapoxy, integrated in like a more complex solution, for example, for cyber threat or for hunting indicators of compromise or for adding value in this field like security? And
Yes.
how do you see its expansion in the future?
Yeah,
Okay.
so in terms of cybersecurity, I discuss with US researchers, and he say it's very interesting to collect information like perhaps Shodan is doing, Shodan, sorry.
Maybe also census, if you heard about it.
Yeah, so you can combine that because Scrapoxy is a good help to manage 1,000 million of proxy. So it's a new layers. Some company already use it from Azure. So it can be clearly a help. If you want to plug it to OpenBullet, please make a pull request. And for the expansions, I developed Scrapoxy 8 years ago. I stopped. A lot of companies use that. And I restart to the last version 2 years ago. And now it's increasing very quickly. So we'll see.
Great. That's great. Thank you.
Yeah, I think there is 2 questions.
Hey, thank you. So my question is with regards to, let's say, bot detection rules. So you have a lot of these, let's say, solutions that you're using for scraping. They can be singled out by different web application firewalls that are using TLS fingerprinting, JA3 signatures in order to block unwanted clients, so to say. So my question is, are you aware of any like middleware solution that you could put between your scraper and the target? I think the mic is dying on me. Anyhow, so are you aware of any middlewares that you could use between your client, scraping client, and the target application in order to kind of emulate?
A tip that I recently saw is not a middleware. There is a new tool, open source tool like BotWrite. So it's solving the captcha, doing all the puppeteers playwright, I think, playwright stuff. It's more this kind of layer that you will add. So it's more something with headless browsers. More and more that I'm seeing that Linux is banned. So use Windows. We are setting a lot of Windows farm because the fingerprints clearly allow you to pass the protections. So I won't enumerate them. But to be honest, when I come here, I use the Violet company, you know the names. It forbid me to buy my ticket on Linux. So I have to switch on Windows to buy my tickets. And more and more companies are blocking Linux. So my advice is to use Windows for scrapings.
Yeah, actually, with regards to Playwright, if I'm not mistaken, it is using a headless browser. Yeah. But obviously, that is much slower than if you would use some with in Go or CLI based. But at the same time, I managed.
Yeah. You have a fresh one.
Yeah, let me try the other one. Can you hear me well? Okay, cool. So I managed in certain cases to bypass such, let's say, protection rules by changing up the cipher suites and the algorithms of the TLS configuration of the tool. But I was, really curious if there would be an option to have some kind of, middleware in order for me not to need to go into the source code of every tool, make some changes if possible, and then try it again.
Unfortunately, not. They are adding more and more protection on the website. We saw clearly an increase last year of the difficulty. You have two choices. You use perhaps Playwright, more generic solution, and as you say, it's slow. And if you want to quickly get the information, so you need to generate or get the antibot tokens. And to do that, there is no solution than understanding how to send the correct payload. You won't generate the token because it's a UUID. You send all your information and you get a tokens. And the reputation is just stored on the database of the antibot. So you have to send the good informations. And that's where you can forge the informations. But clearly you have to understand the payload and reverse engineering, and perhaps every 2 days they are changing the payload. It happens. That's why the prices of the antibot token payload generator are very, very expensive. Yeah. And I think yeah.
First of all, thanks a lot for the presentation. It was great, and I love the graphics. So my question is, do you see something coming up in the future that organizations could use to put an end to botting? So obviously it's a cat and mouse game constantly, and you just can't get rid of bots, but is there something coming up, like a new technology, a new architecture, something that you see being effective in curbing bots?
Yeah, there is the virtual machines that I presented. So we already saw that on some antibot actors. There were some initiatives from Google to put certificate on materials to do that, but they were the opposite side, so to lower the signals. So now, if you activate, it's called the privacy box. If you activate that, the privacy box, it reduces the signals that an antibot can collect. And it will be more generic and spread on different browsers. So in the future, they will collect less information. So they have to find other solutions. That's why I saw this kind of graphic fingerprinting on the 3D. That's interesting. There is audio fingerprinting and many others. They will add more layer, but as you said, it's cat and mouse game. Hopefully they will stay on that, so I've got a job. But clearly they will that small step. And the most difficult part is now they find a technique to have something new every 2 days without deploying something on the customers. Because that was the previous part. If you deploy the antibot part on the Android applications, you have to release the new versions. So you cannot release a new version every 2 days. You can release that every month, perhaps, but it's a pain in the ass for the customers. So now they just run a view browser, a web browser hidden. You know, it's an Android components, and they connect to the antibot to gather the informations. So as the antibot code is now stored on the antibot server, they can change that every 2 days. So it depends on their R&D.
Awesome. Thanks.
Yeah. There is another questions? You tell me when it's finished.
Hi.
Hi.
What do you feel about this architecture, antibot architecture, being used in DDoS attacks, and preparing this architecture with a farm, and let's just take the JAP3 TLS fingerprint, and preparing, I don't know, tens of thousands of these fingerprints and initiating DDoS attacks. Is there a danger in this? I mean, not in the DDoS attacks, in presenting this architecture, and could it be used for DDoS attacks?
Yeah, there is a huge step from showing this schema and deploying it. So, but clearly, if the team has the knowledge to do that, they can do. You cannot prevent DDoS attack. You know, it's like saying, okay, let's stop web scraping. So let's stop all the data. So let's stop Google search, by the way. So yes, I think I'm not investing on technology which can be used for this kind of attack, because first I don't want to go in jail, and I think it won't help anyone. But clearly you can use that, you can combine that with OpenBullet 2 and do it whatever, but that's not what I'm recommending. So I've got also some slide. I didn't show you how to stay on the legal part. So legal part, if I want to give you some tips. So just collect public data, non-personal data, non-GDPR data, and don't log in. If you are doing that, it's legit to do web scraping now, but it's constantly evolves. I think that's all. Thank you very much for your patience, and have a nice conference.